The broadcast is now starting. All attendees are in listen-only mode.
Well, good afternoon, afternoon in Colorado and in the East Coast. We have a webinar, Better Buildings webinar today, managing buildings during a shutdown and bringing them back online. This session will be recorded and archived on the Better Building Solutions Center, along with a PDF copy of the slides. We'll be holding a Q&A period at the end of this webinar, so please submit your questions through the questions box on your GoToWebinar panel on your right, generally. The agenda today, I'll give a few introductions about the Better Buildings Alliance. The team is myself, Marcus Bianchi, engineer with NREL. Miles Hayes is also an engineer with NREL, and Michael DeRue, the three of us with NREL. We have two speakers. I'm very honored that they agreed to give the talk. George DuBose from Liberty Building Forensics Group, and Mead Rusert, Automated Logic. Then we'll have a discussion about that. Next, please. I think it's important to say that the Better Buildings meeting, the summit that was going to be a presential one, will be a virtual summit. I'm not going to read all the details, but in the slides you have a way to follow and register for it. There will be timely webinars and peer exchanges. The full schedule can be viewed like somewhere else, and you can register just to make sure that you know that the registration is free. Next, please. We have a series of research team updates. They will be all listed in this document. I'm not going to go through each one of them, but if you can click through, Nina, so we can actually show. We have a series of recent publications in different areas. And we also have some updates that are coming up on the new publications that are being worked on. Fault detection and diagnostics, thermal energy storage guide, and we're working on trying to connect BAS to GAP buildings. Next. We have an HVAC resource map that is accessible and available, so you can look at it in this link. Next, please. And very important, on Monday, I know it's very, very close. On Monday, we have a webinar, another webinar just like this one, on managing HVAC systems to reduce infectious disease transmission by Professor Bill Benfleff from Penn State University. It will be at the same time, actually, and you can register, to attend that. Next, please. Then we come to our two speakers. First, George DuBose will talk about managing buildings during a shutdown and bringing them back online. He brings over 25 years of experience in building forensics with a focus on failures related to mold and moisture issues. He's a co-author of 3 manuals on IAQ and mold prevention, and he has been president of Liberty Buildings Forensic Groups and has worked on a series of building envelope failures. Over time, I interact with George many times in the ASHRAE, so he will take from here. George?
Thank you, Marcus. Good day, everyone. And I trust everyone is healthy and well during this time. I want to welcome you to this first part of the presentation, which is the one I'm giving. And my name is George DuBose, as Marcus indicated. I had 2 other colleagues that helped prepare this presentation today, Donald Snell and Nate Sanders, also from my firm. So I want to point them out and their involvement. After me, in part 1, we'll have part 2 with Mead, Rusert, and then, of course, as Marcus indicated, a Q&A at the end. Our sessions are fairly short for a subject matter like this. So at least for my sections, I'm going to point to some resources that have been developed by organizations like ASHRAE and the good work that they have done, but hope to offer tips that may be more unique to our experience on projects related to this matter. Next slide. Just briefly, who are we? I mean, who are we as a firm? We're a firm of architects, engineers, contractors, and industrial hygienists. We do focus on building problems that mostly fall into the area of HVAC and building envelope issues. Now, what's important, I think, for this talk is that some of our larger work on the problems stem from a combination of issues of building envelope and HVAC systems. And as you can imagine, these problems impact the building and many times the business operation itself. So sometimes it does result in the need to recover cost. A lot of times the impact can be minor and not noticeable to the occupant. Sometimes, though, the problem can be significant, but still allow the building to remain operational and occupied. This third area, though, and this is where our experience comes to play for this presentation, is that sometimes the problem can be significant and the building's vacated or even evacuated. And that's this last item where these buildings have been vacated, is where I hope to bring some insights to you today. I'm also going to share with you another area of experience that we've had, which is after the financial crisis of 2009, where we did help clients either idle buildings or even mothball them in an effort to do things like preserve cash flow. And I think that particular era and what we learned from those buildings helps us with where we are today. Next slide. But we can learn from the past. Certainly closing a building has risks. There's risks watching or monitoring a closed building as it sits there idle. And then of course, reoccupancy. We need to know what those risks might be and mitigate against them as well. So closing a building does have risk, and the past has shown this to be true. This is especially true today when not only are we closing buildings, right, but that we had to do them in a very abrupt manner, and that our resources that we're used to having may not be available because of the stay-at-home order. So we had limited resources in closing the building and even limited resourcing and managing the building. Monitoring a closed building has risks that many of us do rely upon the building to be occupied and the presence of have a human presence in the building to give us a trigger that something is wrong with the building. And when those buildings don't have occupants, we lose that advantage. The risk of a vacated building is that we no longer have that presence. And so we do have to find a way to supplement it by other means. And of course, certainly reoccupancy will have its risks. There are technical risks related to restarting systems, reusing systems that have been stagnant or even turned off. But there's also non-technical risk. And that is, will my occupants actually feel safe to reoccupy the building? Whatever we do, we want to avoid a start-stop scenario where we occupy the building, only then to vacate it because of an incident that then causes our occupants to lose trust, not only us as managers of the building or owners of the building, but also in the building itself. Next slide. So most of us are here, right? We've closed or partially closed our buildings. We have limited resources now to put towards monitoring the building. And we may even have several tasks that when we close the building remain unfinished because we had to close the building so quickly. Now, ASHRAE has a great resource that you can go to that gives you a fair amount of detail and recommendations of what to do when closing a building. If you Google ASHRAE, COVID-19 frequently asked questions, you'll find it. I'm not going to get into all of the detail that's in that guidance, but it offers you direction on how to handle HVAC system, whether you have a BAS system or not. It helps you with what to do with your boiler and a distributed hot water system. It helps you with your cooling tower and your chilled water system, gives you guidance in all of those areas. It walks you through issues with your plumbing and even some elements of your building's electrical system. And it even gets into some specialty systems, right, like fire alarm and fire sprinkler systems and what to do about that. So I'll point you to that document. I'm not going to go through it in detail in my presentation, but I really do recommend that you access it. What I want to share with you is how some of our clients have approached other areas not touched on by organizations like ASHRAE. And for that, let's look at a case study. Next slide, please. So let's look at a case study. Here's a resort building that we're involved in that went from 90% occupancy to shutdown. Now this particular resort, you'll find it on the luxury end of the hospitality product. And so of course with this shutdown, they lose much of their staff of over 1,500 employees. Many of them are in housekeeping and engineering. Fortunately, several years ago, many of these kinds of large resorts, and these kinds of properties got away from the traditional hotel operations silos that existed with housekeeping and engineering, where they were separated and often very distinct teams. And many of them began to operate under one umbrella of a resort or property operations. And often this position was held by someone that did have hotel engineering experience. And also part of this organization, amongst other team members, was security. And so what this resort had to do now is we're going to have some basic skeleton crew on property for handling certain issues, including security. And so they had to now look at how could they distribute across other team members the duties for monitoring areas of that resort that normally would have been performed by, under the regular duties of housekeeping or engineering techs. It also meant that they had to develop, a sampling of rooms or areas to inspect during the shutdown so that they could now identify trends and be able to connect the dots as something was developing into a serious problem. How else are you going to handle nearly 1,000 rooms? You're not going to want to handle it reactively. You're going to want to set up a sample of those rooms and stick with that at a regular pattern of inspection. Remember, many of these resorts are older and don't have full-scale BAS systems in place to conduct any kind of monitoring. The newer ones, of course, do. That would be a different approach, and Mead will pick up on that matter in his presentation. So where did we land? Well, we landed on a 10% sample size of the rooms, consistent with what would happen if we were doing a building assessment. And it's important that even though we're talking about a resort here, that kind of sample size can be applied to any building type out there, whether it's based on square footage, number of rooms. It just simply has to be a set sample size. And you have to, and in our case of the resort, we're choosing rooms with differing exposures and elevations. Why? Because different rooms or different exposures and elevations will act differently. We choose rooms on different floors and configurations. We made sure that they were broadly distributed across the resort. And we want the sample to be consistent so that we can separate the results of the inspection from other more reactive matters that we have to tend to in the result. So that's what this sample is intended to do. It's intended to give us a systematic connect the dots approach. Then you had to decide what to inspect. The best source to understand what could happen in your building is to look at historical data from the work order system. And so we developed a hot list of key items to track in inspections. And of course, you have to have room, right, for adding to the list because things will change. We use tools and processes that allowed the inspector to cover large areas quickly, and we weren't worried about a detailed inspection at this point. And of course, focus on areas that were perhaps, and this is important, low frequency in occurrence, but high consequence in either cost or impact to the building. Instead of focusing on items that were of low consequence, even if they were of higher frequency. So that's how we landed on a monitoring system for a result of over 1,000 rooms, a resort of over 1,000 rooms. Next slide. So what are the risks of watching a closed building? Now that you've closed the building, now that you've started an inspection, what risks do you want to look at? Again, I'm going to point you to that ASHRAE document, but I'm not going to get into it in detail, referenced earlier, because it does give really good direction what to do with the HVAC system and your plumbing system, even some of your electrical systems. Most of them are very common sense and very, very direct. It's very accessible information. But what I want to point out here is that there may be a little bit different direction than what ASHRAE has provided, is that you really need to adapt that direction, right, to your specific climate zone. If you're a facility management group that has buildings across the country or even across the world, you need to make accommodations for your climate zone. For example, in a humid climate zone, you want to make sure that you keep your indoor conditions, even in setback mode, at or below 6-degree dew point. That's something different than what ASHRAE has put out right now. They'll let you actually rise a little bit larger than that, higher than that. I wouldn't recommend that in a climate that's a humid climate. It might be fine in other climate zones. Secondly, with exhaust systems, the current direction now is just turn all exhausts off. Well, in most air-conditioned buildings and in most climates, except for very, very, very cold climates, you should really consider adjusting the systems so that you reach a certain positive pressure of about 5 pascal. That may sound very technical and sound very detailed, but this is a common guideline for design and operation of buildings. And it's a little bit different than what the industry is pointing to, which is just completely turn off all exhaust systems. Many of us could have energy recovery air handling units that if we don't make careful adjustments to them, we can result in building pressurization conditions that are very adverse to our objectives. So it's not just direct exhaust, but it's also airflow streams that are being exhausted from the building through some of these large energy recovery air handling unit systems as well. So why is the good positive pressure, of course, important, especially in a building that's unoccupied? Because it's almost like having ServiceMaster or ServPro in your building 24/7. If you're exfiltrating on a continuous basis a slight amount of conditioned air, then you go a long way at having a significant drying mechanism in your building envelope, even if you experience some rainwater leakage during that closed time period. So it's important, I think, to adjust to good pressurization. I don't want to get into details about bullet number 3 here, because we just went through an example on the resort of how you could have enhanced inspection and walkthrough. Same thing would apply to other buildings and would fall well in place for this third bullet, enhanced walkthroughs. And of course, occupant screening. I mean, that information is I mean, there's just a significant amount of information out there, including great guidance by the CDC. And I mean, I'll note that from the clients that I visit, most of you guys are already handling this very well, as far as occupant screening and managing occupants coming in and out of the building and incident tracking, all those kinds of things. So I'm not going to spend any time on that particular item, but it's an important factor. Next slide. I'm going to go through this quickly because what's unique, of course, about schools, that there are some buildings that are seasonal, right? And that they're very comfortable with being unoccupied for a period of time. But just quickly, the things that we did for this particular building, because it's being, for this particular school that I'm talking about, because it's being unoccupied for an extended period of time, follows a lot of the same items that I discussed in the previous slide, except for that they had through-the-wall units. So we want to make sure that we're closing outside air intakes to things like PTACs, or there may be unit ventilators in your case. It doesn't matter whether it's a hotel, a nursing home, or classrooms. Exhaust systems, again, in this case, were minimal, so we chose to keep the common space exhaust operating, but we turned off bathroom exhaust and kitchen exhaust, reducing the outside air to the minimum value for the central air handling units, the constant volume system, and just let it track in its normal sensors. We did, however, if you have the luxury to do this in your building, I would recommend it. We did, however, deploy some sensors so that we can make adjustments to that if there were an issue. Again, in this case study, just like in the previous case study, there was a burden on the employee on what to do before they entered the building as far as reporting and tracking. Of course, there's a burden on the employer if something occurs and to provide proper PPE and the tools in order to run those checks. Next slide. So what do you do now if you're going to open up the building? The first section to the ASHRAE document goes into considerable detail also with reopening the building, including an introductory section that gives you direction on communication, and it gives you direction on which exhaust system to turn on, which exhaust system to turn off. And so it's fairly complete. I'm not going to duplicate all that here in this particular presentation, but it gives you the detail related to HVAC system, points to ASHRAE standard 180, which has tables to show you the typical maintenance on equipment that should take place for the system that's been in operation, what to check. It gives you kind of a basic functional checklist, walks you through airside systems, even recommends increased filtration, right? Increasing the level of filtration in your handling units, which I think we're all considering now, although that's difficult to do in an existing system. And then they go on, of course, to say, hey, if you can't increase your filtration, you could consider portable units in high traffic areas. I found those to be particularly noisy and not very conducive when we try to use these high filtration portable units, but it may be something that could apply to your building. They walk you through what to do with the cooling systems, heating systems, BAS system, and I'll leave the detail of that to Mead. One big item, of course, when it comes to these MEP systems, and I'll just get through it quickly, the plumbing systems and dealing with Legionella if it's been stagnant. So you need to make sure that you're addressing those kinds of things. And then, of course, your electrical and your specialty systems. Let's talk a little bit about envelope, the second bullet on this slide. We would recommend that you visually inspect for the very basic windows and doors that may be left open, repair any damage that occurred. We'd also recommend that you conduct a basic moisture survey of at least some portion of the exterior wall, of the interior side of the exterior wall, for evidence of bulk water intrusion. That could be, using something like infrared, very quickly scanning the facility, but at least some portion of it, if not the entire interior of the exterior wall. And then, of course, these next two items, product expiration and cleaning and disinfection, I'll mention a couple of things about it, but they're very well presented in guidance by the CDC, is that, of course, you want to inspect for any kind of expired products, chemicals, food items, and dispose or replace them. Now, the last item I want to spend a little bit of time on, which is occupant trust. And that is this. It seems that now in the general population, we find ourselves with differing degrees of confidence on the reoccupancy and reopening of buildings and facilities. And there's some that are eager to get going, and then there's the opposite end of the spectrum for those that are very hesitant to reopen or reoccupy facilities. And that makes the degree of occupant trust that you have in your building very important. The most important thing I think we must avoid, as I mentioned earlier, is a scenario where we occupy the building and then we have to now vacate it because the occupants have somehow lost trust in the building and us as managers. I'm going to point out a little bit of what I learned in the 1990s and again in the 2000s based on the work by Peter Sandman when it deals with occupant outrage, and also follow on by David Odom, specifically related to some of the work that we've been involved in, where occupants lost confidence in a building by looking at a particular case study. Next slide. So I'll do this quickly. There's the issue of being safe and feeling safe, right? It's all about perception of risk. And occupants, your perception of risk, as Peter Sandman indicated, and the practice of risk communication is based on the premise that the public assesses risks more in terms of moral or emotional issues, which they call outrage, than quantitative criteria that we as consultants and engineers might call hazard, right? I mean, we could specify the hazard or the exposure to the occupant. That's not how all building occupants perceive the risk of the hazard. So really looking at the risk and what an occupant is going to look at the risk of reoccupying your building, risk is really the equation of hazard plus outrage. This moral or emotional issue that's attached to it. So it's the actual risk of the hazard plus the level of outrage that the occupant has. And so the public's perception of risk is not based purely on physical harm that the exposure possesses or its association with mortality, but rather on a combination of the hazard and any accompanying moral and emotional issues. And that's, I think, what is important about what we're facing when we're putting occupants in the building. It's a different perception of risk than what we may be used to dealing with. Most important thing is to keep trust, always. Act quickly in response to occupant issues, especially at the beginning of reoccupancy. Involve the occupants in the management of their own risk. Now, this is especially easy to do with our current situation where occupants can be involved in some level of disinfection, even if it's localized. And of course, they're involved in the use of PPE. And if occupants don't have a role in their own safety, then they are more likely to perceive the risk differently. Rebuilding the trust is a difficult thing. Next slide. Very briefly, this particular building was evacuated. It's a classic indoor air, the project that I'm talking about is a classic indoor air quality problem. It was not this building that you see in the picture. I'm using it as a placeholder in order to protect the innocent. But it was a classic indoor air quality problem. And the main point to this is that the building owners lost the trust of the occupants. And what was initially the technical cost to fix the building, right, became magnified 2 or 3 times a greater amount because the perception, that portion above the typical fix, the perception of the problem required the owner to invest dollars into it in order just to get the building reoccupied. So that's the lesson we learned just very quickly as I run out of time here with this issue of occupant trust. Next slide. So let me just close. Look to past closures because that can help us now. Obviously, it's a little bit different with COVID-19, but a lot of the same kinds of trends and lessons can be applied. Remember that even if you do all of the adjustments that something like that, an organization like ASHRAE recommends for you, you at some point in time have to know that the building is still an active building, even though it has occupants, and you do have to put in place an enhanced inspection process, the one I discussed, in order to protect the assets. And then when it comes to reoccupancy, you can go through and have all your vendors come in and do everything that's technically prudent for disinfection and cleaning and setting up the systems and any kind of enhancements to your systems. But it's as much of a non-technical trust issue for your occupants, and at all costs, avoid the problem of reoccupancy of a building, and then because of a misstep, losing the trust of the occupants in that building, and therefore the occupants of you, perhaps as a building manager or building engineer. So with that, I will close, Nina, and we can pass it on to Mead.
Okay, this is Marcus again. Just to remind you, we're collecting questions as you go, so submit questions through the box. Passing to the next speaker. Thank you, George, by the way. To the next speaker, Mead Rusert. It's president of Automated Logic Corporation, a leading provider of innovative building automation and energy management solutions that maximize energy efficiency and ensure occupant comfort and engagement. With 30 years of industry experience, he brings a broad background to the position, including executive roles in engineering, product management, and marketing for commercial HVAC products at Carrier Corporation. He holds 3 patents related to temperature control algorithms. Mead, please, it's your floor. Thank you.
Thank you very much for that kind introduction, and good afternoon, good day, everybody. Again, my name is Mead Rusert, Automated Logic, and it's an honor to be speaking with you all today. I'm also today representing one of our business units called EcoEnergy Insights, and that business focuses on providing remote energy efficiency and maintenance services, leveraging our IoT data analytics platform, global command center, to execute HVAC services remotely at scale with over 17,000 buildings and 150,000 assets under remote management at the moment. So most of the information I share today will be in the context of our experiences in that building, notably around multi-site applications. Next page, Nina. Yeah. So they can see our businesses. Let's go ahead to the next page. So stating the obvious, but obviously a rapidly evolving crisis here. You know, in the retail context, many retailers have closed, but many are still running, but within new constraints. Reduced operating hours, different staffing, curbside delivery, all the complexity of social distancing and so on. So change has been rapid and constant. And unfortunately, it's becoming clearer and clearer that, this will not be a situation where we flip a switch and go back to normal again. So it's becoming clear that this state of change and volatility in terms of operations will continue for some time. Next page. So the challenge is, how do we navigate in this environment as building managers and so on, particularly in the context of conflicting objectives? The first one, building trust. I really enjoyed George's remarks regarding building trust in the building. I think that's paramount. Employees have to feel comfortable coming into the building. As someone has responsibility for a direct building and a factory and so forth, it's really critical that the employees trust coming into that facility. And similarly with customers, obviously in a retail environment. That, along with taking actions in line with the guidance, that George suggested and ASHRAE and others, and I won't go through that in detail, but there's, again, references in the back of my pitch as well here for those interested. This notion of managing uncertainty, a lot of changing needs that I talked about. So it's not only changing needs within a building, but if you think of a portfolio company like a large retailer with thousands of sites, you think about the different situations in different cities, which means different work stoppage rules or different policies, or political policies, different building types, creating different business models, different climate zones, all of which in turn then flow down to the facilities folks around managing the impact in terms of changing operating parameters, hours, schedules, temp humidity, so forth and so on. So a lot of uncertainty there, and the guidance certainly keeps changing, which really points out in the last column this concept of a need for agility, the need for speed, ways to deal with changes and managing these building assets with limited on-site staff and limited service resources, if something does go wrong. In addition, another big challenge, I think, for building operators is if managing a facility manager and, your business has decided to shut down a whole bunch of stores, the business leadership might think, well, of course, the energy usage will be zero. But that doesn't obviously, that's obviously not the case. You got to run the lights, you got to ventilate, you got to do all these things. So balancing cost with the long-term health of the building, as George pointed out, is very important. Next page. So just a couple examples of the guidelines. And the first one is an ASHRAE statement, which I think is very timely. In fact, getting back to the trust question, I had an employee today actually ask me, she said, hey, Mead, I'm hearing that, maybe we shouldn't be running the air conditioners. And, I think it's important that, we take a step back and think about all the information that's swirling around in the industry and through the press and so forth. So I'm glad that ASHRAE came out with a pretty definitive statement. A couple of things I want to highlight on the left. I won't read the whole thing, obviously, but, one, they officially oppose the advice not to run commercial. In other words, do run commercial HVAC. The second statement around transmission to the air is sufficiently likely that exposure to the virus should be controlled. And the last statement in that second paragraph, changes to the building operations, including HVAC, can reduce exposure. And the last paragraph, really focusing on filtration, ventilation, and the last sentence around, in general, disabling the HVAC is not recommended measure. So, even well-informed people are kind of confused right now. So I'm really glad that a lot of industry guidance is coming out. There's a lot of resources available in that regard. Another one to the right I want to point out, and I like this one because it's pretty simple, the Eurovent guideline that came out on April 10th. What people seem to be converging around is this notion of increasing outdoor ventilation and managing humidity. Increasing humidity to a certain extent, but you got to keep it, low enough, as George pointed out, to prevent mold problems. Now, all of that's easier said than done because people want to move quickly, but we're constrained by the systems we have in place, and that's obvious. But a lot of these buildings, particularly retail buildings, have constant volume rooftop units, and their ability to bring in a lot of outdoor air or radically change their performance, can be limited. Fortunately, most of the U.S. has been rather temperate this spring, but as we go into summertime, the ability to manage that to be increasingly difficult. Next page. So, what are some of the critical success factors that we've kind of noticed and explored and so forth? So first of all is the industry best practices, which I talked about, George talked about in detail as well. But then the next piece becomes really important, especially when you're dealing with large multi-site operations. This notion of standard operating procedures. And I think it makes sense to break it into two pieces. There's a SOP during shutdown, the situation we're largely in now. And that's around how do we operate to minimize cost while protecting our buildings, doing things like remote cyclic testing of rooftop equipment, for example, kind of keeping things moving, keeping things exercised, and I'll talk more about that later. Then the second part is how do we operate in the future? What will be the new SOPs? What elements, if any, will be applied regarding ventilation, filtration? How will the operating hours change? That really, now is the time to be really finalizing all of that, to give the vendors and, all your partners time to really respond, act, and prepare the buildings for this future state of operating procedures. Now, let me drill down a bit further here under the SOP topic, just to provide a little bit of color, about reality. So today in shutdown situation, one of the practices to be considered while a building's in lockdown is to do an air purge. If it's been shut down for a while, to get fresh air in it, get the humidity back under control and so forth. Unfortunately, when you're in a circumstance where you have a large multi-site operation with vintage of equipment, vast vintages of equipment, different manufacturers and so forth, different BAS systems, there typically isn't a standard easy button that says purge, right? You can't just hit the purge button and just have it happen. So that's an example, just one very specific example, that there's work required to go from a SOP change and moving that from thought to action. Okay, to take action on this requires logic changes in many cases and a process to go back and touch all the building assets to actually put it in place, and then return it back to normal again, right? So, there's a lot of complexity here. The simple is actually a little more complex than sometimes we realize, but it certainly can be done. Then finally, the next piece, quality assurance. So once you've taken some action, did the action actually happen? You did a work order, you sent a work order to your service providers. Did the action actually happen? And was the effect, what you expected, the cause and effect relationship? Did it make sense? so that piece is important. And then the data piece is really important. So all of this is all the simpler if you have access to data. Now, if you have a good automation system strategy already in place, you're well along the way, you're in pretty good shape. But many folks, aren't in that position. So it takes a little more brute force. But we can do things. We can do things like bring in weather feeds, to get a sense of, dew points and humidity levels and so forth. All sorts of things that can be done at scale to try and manage through this process. So, the key piece here is this is a great opportunity to leverage a good EMS vendor that not only monitors the buildings, but is skilled at taking remote action, remote resolution, and can close the loop with a good quality system. So we can move at speed, scale, and with confidence. Next page. So I'm going to provide just a couple examples here, some mini case studies. So here's 4 examples. These are all large multi-site customers, all 1,000+ sites around the U.S. And there's a diversity of customers here, both in terms of vertical market, big box retail, department stores, quick serve restaurant, but also the situation they've been put in based on the role they play, in terms of what they're selling and what they're doing. So in the first case, in that situation, their hours were reduced, but those hours vary by location. So, you have to manage through that complexity. And in that one, the shift was really from a real, intense focus on energy reduction to shifting the focus from energy reduction in the short term to, ventilation and giving ventilation more consideration. Okay, so in that case, they actually had, pretty sophisticated, mature system in order to do that. So that was something that could be done. And, with those adjustments and change in operating hours, there was a, energy reduction as you expect with reduced operating hours, about 5 to 6%. Now, as you move to the right, another situation, this client had to shift to curbside delivery and close some stores. And what I'll also mention here, I forgot to mention at the outset, is that even within each of these customers that are multi-site, they all grew sometimes over decades, which means there's a big challenge here in that they have a wide range of systems, PMS systems, HVAC systems, vintages of those systems, largely constant volume rooftops, but some are, variable volume and new technologies and different staging technologies, different suppliers, and different capabilities, of the equipment across all those vintages. So having a good inventory of the equipment is really important. So anyway, moving to big box number 2 here. Again, that's a little bit more brute force. They have multiple BMS systems in that. So in that one, we've had to basically go in there, make changes, a bit brute force, and do things like purge sequences and so forth. But pretty intensive activity to do that. The third one, stores all closed in the process of their startup thinking at the moment. Okay. And then the fourth one, quick serve restaurant, which is an interesting one because that's basically a thermostat control situation, a very, very light BMS. So we're managing that through, remote set point changes and so forth to try and manage through that system. At this point, it's drive-through only, so the focus is in the kitchen area. But as we think about reopening more broadly, broader mechanical system questions come into mind, with QSRs around exhaust and kitchen exhaust and ventilation and so forth that I know people are thinking through. So, fortunately, in these cases, in most of these cases, we're already engaged. We had a system in place, and we were able to make changes very quickly, usually within about 48 hours, and be able to manage these changes on an ongoing basis. but also as we engage with new clients in this environment, this notion of stabilizing the system and then, moving to the next step and moving them through the journey is becoming very important. Okay. Next page, please. Okay, so what I'd like to do here is this is a operating procedure or a protocol that we're starting to use kind of through the journey. And a caveat is all these procedures vary based on application, client, mechanical systems, all that. But, big picture, again, this is multi-site retail. Let's start on the far left. And this is a progression over time, is the way I'd like to think about this. So if you start on the far left, imagine we're in mid-March right now, and you've just closed down 1,000 stores, right? And then fast forward a couple of weeks, those stores have been closed down a week or two. They were closed rapidly, vacated essentially. What do you do to stabilize them? Well, this is where a purge comes in. So during lockdown, it's important to maintain good indoor air quality, to provide a safe environment for the cleaning staff and others that happen to be there, even in a shutdown. And, the altered occupancy patterns and loads, humidity levels, can be conducive to mold growth. So a purge, makes a lot of sense. And so a sequence remotely managed purge cycle is a key element to kind of reset those buildings while taking care to make sure you're managing moisture and doing it the right time of day and night. The dew point levels are appropriate to do that. The other thing I'll add is most of these retail sites, even though the more sophisticated BMS sites don't have a lot of relative humidity data available. So what we typically do is tie into weather feeds, and before we take actions, we look at the outdoor conditions and do our best to make sure that we're in an acceptable moisture regime before we take actions. So now the building's stabilized, and so now let's pretend we're sort of in April, and how do you keep that building, operating properly? So that's the phase of the cyclic health checks. So in that mode, every week or so during the lockdown period, it's important to periodically review performance. So in this phase, as part of this exercise, we operate them, typically rooftop units, in a full load. We try and simulate a full load environment. Health check we usually do about once a week, about half an hour per RTU, batching them in such a way to avoid demand limit problems. And the output of that process is to verify things like supply air temperature pull down, to make sure compression's working, operating no faults, remotely fix what is possible, and then create prioritized work list for the balance so that the clients can have sort of a managed process to kind of manage the flow of work to their service providers. Next phase, preparing for startup. Really important. This is where, we need to all work together with the clients to really define the future state operating policies, from, ventilation to something as simple as operating hours, because control programs have to be updated if those SOPs are changing. And it's a good time to work through those prioritized work lists prior to opening. And then finally, moving to operation. So in this phase, what we're envisioning here is that a solid day before scheduled opening or before pre-opening activities, the rooftops will be operated in an occupied mode for 24 hours to ensure that the assets are in a good condition, while providing another benefit around purging accumulated contamination, so forth, and getting the buildings restabilized per the store policies. Okay, so that's kind of the journey that we see from close reset, periodic health checks to stay in front of the maintenance, given the very dear resources in terms of service resources that are available, and then getting back to operation. And then just for closing, I just left some resources here. The ASHRAE resources that George mentions are fantastic. There's several others. Contact information at the bottom. Also contact information for my colleagues at EcoEnergy that are doing most of this, START protocol and so forth. So thank you for your time. And I'll turn it back over to the team to moderate questions.
Thank you. That was great. We have time for answering a few questions. We still can submit some questions already. Miles is looking at the questions, and can you ask the first one, Miles, that we got?
Yeah, I'm kind of combining a few of the questions here. There were a lot of questions that came through regarding ASHRAE recommendations for PPE, whether that be just during a normal building walkthrough, or recommendations for wearing PPE during filter changes and that sort of thing.
Sure, and Miles, this is George.
Go ahead. Yeah.
I was just going to say, my answer in the chat while it was going, certainly CDC has wonderful guidelines for recommended PPE. OSHA doesn't get very specific in their guidelines right now. They do help kind of give some categories of low, medium, high risk jobs or employment situations, but they don't get too specific to something about what an HVAC person might do. But I'll tell you, in our work, if we can't practice social distancing when we're going into a customer's building or on a site, then we do wear PPE, which includes gloves and masks. If it's unoccupied and no one's there, we don't necessarily wear a mask. If we're outdoors, we won't necessarily wear a mask if it's an open construction site, unless we're in close proximity in a meeting or watching a particular test, etc. I will say in our area, a residential contractor has his technicians wearing, PPE, including a mask and gloves for any task, regardless, and in any home that they go in. And then similarly, a larger mechanical contractor has his techs in PPE, mask and gloves. Once they leave the truck, going into the commercial building, whatever they're doing there as far as tasks are concerned, and including leaving until they get back into their truck. So I haven't seen that kind of particular guidance. ASHRAE does suggest you consider wearing PPE when changing filters and inspecting air handlers, but they don't specifically, they don't provide specific direction, but they certainly do suggest you wear PPE.
Thank you, George. A couple other questions came through that were more specific to operating HVAC systems to reduce infectious disease transmission. And I just want to make sure that our audience is aware, Monday, May 4th, I put a link in the chat here. If everyone can see it, if you can't, be sure to reach out, but we'll have another webinar that's more specific to that question. Sorry, I'll move on. A couple other questions came through. Mead, maybe more specifically for some of the topics you're bringing up. A lot of our audience have a number of, let's say you've got 1,200 rooftop units, and you may not have the necessary control system to automate that. What's your suggestion for them?
That's a challenge, obviously. With large volumes of units, I'd say, first of all, if you have a control system in place and you're having a hard time sort of deciphering the logic that might be in there or so forth, and you need help doing that, reach out to your controls vendor. They should be able to help you out because those can be pretty specific if you haven't been trained by them on how to do it or whatnot. So I would certainly do that. If you have air handler systems in large buildings without a control system, that's probably another challenge. I guess I don't have a great answer for that. They're probably in some form or fashion, I need kind of more specifics, but some form or fashion, I'm sure they're networked together particularly in a campus environment, and they should be able to be adjusted.
Okay, thank you, Mead.
I'd be happy to follow up specifically if there's a specific question. Yeah.
Sure. Yeah, I'll be sure to pass that along as they're received. A couple other questions that were sort of related here. I'm kind of grouping them together, so forgive me. It mentions like operating toilet exhaust fans during unoccupied periods to prevent like sewer gas buildup. Let's see. I guess I'm looking for the other one that was related to that. If you want to answer that one, I'll keep digging here.
On exhaust fans, I've heard kind of different messages on that. I know, George, if you have a perspective on that, on bathroom exhaust, I've heard on. So I'm not, that might be a question for the infectious control folks on Monday.
Yeah. So this is George. I think that really depends on what kind of building you're in. If you're talking and where the bathrooms are, if you're talking about something that's not a significant amount of exhaust compared to the entire size of the building, like an office building that may have a center core bathrooms, then I don't think you're going to have a problem leaving some of those exhausts on. You're not going to, especially if you have central air handlers on each floor or what have you, maintaining the kind of pressurization you want in your building, and you could prevent the buildup of sewer gas and those kinds of things. Of course, you'll make sure your trap's wet, and that would go a long way there as well. I don't know that's a monitoring thing there, but if it is another kind of a facility like a hotel or let's say student housing complex where you might have exhaust, and in some cases, student housing for an apartment, right? Because every one of them has their own bathroom now, or in a hotel, one in each room. Then in that case, you either want to reduce it very significantly, right? Or you probably want to turn it off because the risk of other issues are greater. And so when you're doing your inspection, if that becomes an issue, then you can make an adjustment accordingly if it becomes a problem. But I would say it depends on the building, and it depends on how the impact your exhaust would have on the building itself compared to, and that varies depending on what kind of building it is. I hope that helps.
Yeah, thank you, George. I think we just have one more minute here. I'm still seeing more questions roll through that are related specifically to reducing the spread of COVID. And I just want to reiterate that we will have a webinar on Monday. If you'd like a link, follow up with a question. I can make sure you have a link to that, but the webinar that's specific to that is occurring next Monday. The last question here, maybe for you, Mead. How could one determine what best relative humidity range is best for operating a building in the mid-Atlantic region during this crisis?
Yeah, I think there's a couple of things. It depends on your application, what type of building it is, what's in the building, and so forth. Is it an office building or like a retail site that might have critical goods inside? But I'm hearing from an infectious disease standpoint above 30% relative humidity, but then you got to stay below the 60-degree dew point as well. So, probably best, again, your specific location, to speak to local experts in the area. But you want to stay within those parameters. You certainly don't want to have it too humid in there, you create building problems.
Okay, with that, I think we're running out of time. I'll go ahead and thank you, George and Mead. I'll pass it back to Marcus to close it up.
Well, thank you so much to the speakers for spending the time and sharing their knowledge. Thank you for the questions. All the slides will be available on the Better Buildings Alliance website, the recording. So I'll see you next time. Thank you so much.
Very good. Thank you.